Welcome to today's deep dive. If you're joining us from anywhere on the internet, you are absolutely in the right place.
Yeah, we've got a really fascinating one today.
We do. Today, we have a mission that requires untangling, well, I guess one of the most fascinating paradoxes in the modern financial world right now. We're doing a comprehensive exploration of Nvidia's blockbuster Q4 fiscal 2026 earnings.
It's quite a complex narrative to unravel, to really figure this out. We are looking at a massive stack of sources today.
Oh, definitely. We've got the official financial releases, the full transcripts from the earnings call featuring the CEO and the CFO.
Plus, a really wide array of media analysis from CNBC, Fox Business, and some independent market analysts to sort of round out the perspective.
Right. And the mission of this deep dive is to make sense of a massive contradiction. I mean, how does a company completely shatter records, pulling in $68.1 billion in quarterly revenue, and yet
See its stock sink 5% the very next day.
Exactly. We are going to figure out what the market is seeing that those massive headline numbers aren't showing. But before we really get into the weeds, a quick mandatory reminder for you listening.
Always important to get this out of the way first.
Yep. All the information and analysis we are discussing today is simply to help everyone better understand the market. It is not investment advice.
Right. Absolutely not investment advice.
Investing involves risks, and you should always do your homework or consult a professional financial advisor before making any moves in your portfolio.
That's a super important foundation to set. We are here to analyze the data, spot the patterns, and connect the dots. We're not here to tell anyone what to do with their money.
Exactly. Because the data we're examining today is presenting us with a scenario that we really haven't seen before in the tech sector. I mean, let's just start by looking at the sheer scale of these financials.
The numbers are almost hard to process.
They really are. In Q4 alone, their revenue hit a record $68.1 billion. That is up 73% year over year.
Which, for a company of that size, is just a massive growth rate.
Right, and if you pull back to look at the full fiscal 2026, it is a staggering $215.9 billion in revenue. For a hardware company to generate that kind of cash in a single year is, it's almost hard to wrap your head right around.
It is. To put that in perspective, they have scaled their data center business by nearly 13 times since ChatGPT first emerged. Back in, fiscal 2023?
13 times in just a few years.
Yeah. And that data center segment is really the engine of this entire operation now. Out of that $68.1 billion in the quarter, data center revenue accounted for $62.3 billion.
Wow.
But what is truly crucial to understand here is the composition of that number. It isn't just the GPUs doing the heavy lifting anymore. It's not just the compute chips.
Right, I noticed that in the breakdown, too. The networking business alone generated $11 billion this quarter.
Precisely. Nvidia is now the largest networking business in the world, which people often forget. They are selling the entire nervous system of the data center.
The InfiniBand and Ethernet technologies.
Exactly. The tech that allows tens of thousands of these chips to talk to each other simultaneously without creating a massive data traffic jam. They aren't just selling the brain anymore, they are selling the entire biological system.
Which brings us to a number in the sources that it really made me stop and reread it. The 75% gross margin.
Ah, yes. The golden number.
I mean, for anyone following the hardware space, maintaining mid-70s margins at this astronomical scale is historically anomalous.
It really defies the usual rules of hardware manufacturing.
Let's break that jargon down simply for you listening. A 75% gross margin basically means for every dollar of sales Nvidia makes, they keep 75 cents after booking the direct cost of making the product.
Right, the cost of materials, the manufacturing, all of that.
And usually, if you are keeping 75 cents on every dollar of sales, you have a giant bullseye on your back. High margins attract fierce competition immediately. Companies like AMD or even custom silicon projects from the major cloud providers should theoretically be eroding that premium.
They absolutely should be.
So how are they holding on to that pricing power?
It is a phenomenal display of leverage. They are holding on to it because they aren't just selling a commoditized piece of silicon that you can swap out. They are selling a deeply integrated ecosystem.
You're talking about CUDA.
Yes, their CUDA software platform. Developers use this software to write AI applications, and it is deeply entrenched in the industry. So if a customer wants to switch to a cheaper alternative sitting on the shelf,
They're just swapping out a chip.
exactly.
Yeah.
They are having to rewrite massive amounts of code, retrain their engineers, rebuild their workflows. That friction gives Nvidia the power to command a massive premium.
And they certainly aren't just hoarding all that cash they're bringing in. The releases show they returned $41.1 billion to shareholders through repurchases and dividends over the year.
Which is a huge vote of confidence in their own stock.
It is. Furthermore, their guidance for the next quarter, Q1 of fiscal 2027, is projecting $78 billion in revenue. That just blew Wall Street's expectations completely out of the water.
Wall Street was looking for something significantly lower.
So the baseline numbers are huge, the margins are defiant of hardware gravity, and the guidance is extremely aggressive. But what exactly are they building that has the biggest tech companies in the world happily handing over billions of dollars quarter after quarter?
To really grasp that, we have to look at a fundamental shift in how computing architecture actually works today. During the earnings call, the CEO kept returning to a very specific concept.
AI factories.
AI factories, yes.
I want to spend a minute on that analogy because it feels really central to their whole pitch.
Yeah.
When we think of the Industrial Revolution, we picture these massive brick-and-mortar factories. They took in raw materials like cotton or steel or coal, and they manufactured physical goods.
Right, tangible items you can hold.
But what the CEO seems to be suggesting is that today's data centers are no longer just passive warehouses where we store our photos or host websites. They have evolved. Instead of taking in raw steel to make cars, these new data centers take in raw data and electricity to manufacture a completely different product. It's exactly tokens.
That is the perfect way to visualize it. Tokens are the fundamental building blocks of AI output.
So for the listener, if you ask a chatbot to write a poem, the words it generates are processed as tokens.
Right. Or if you ask an AI model to create an image or analyze a spreadsheet, the output is essentially constructed of tokens. And the CEO made a very direct, unvarnished statement on the call. He said, tokens are profitable.
But wait, let me play devil's advocate here for a second. The sources project that the major hyperscalers, companies like Microsoft, Amazon, Google, they're going to spend nearly $700 billion in capital expenditures, or CapEx, this year.
It's an unprecedented sum of money.
$700 billion is a massive, almost existential bet. Are they actually seeing a return on that investment just by generating digital tokens?
That is the multi-billion-dollar question, isn't it? For those hyperscalers, compute power now directly translates to revenue. Every piece of enterprise software, every customer service interface, every search engine is integrating artificial intelligence right now. So the faster a company can generate a token, and the cheaper they can generate it at scale, the higher their profit margins on those software subscriptions. The compute itself is becoming the actual product they sell.
And the type of tokens we are generating is shifting rapidly, too. The earnings call transcript highlighted two new buzzwords, two new areas driving this insatiable future demand: agentic AI and physical AI.
Yes, those were mentioned frequently.
I want to break these down because they really seem to represent a massive leap from the simple chatbots we're used to today. Let's start with agentic AI.
Agentic AI represents a massive inflection point in software engineering that has truly accelerated in just the last few quarters. Think of standard first-generation AI as a highly advanced encyclopedia.
Okay.
You ask it a specific question, and it gives you a specific answer. Agentic AI, on the other hand, acts autonomously to solve multi-step problems.
So it's not just answering, it's doing.
Exactly. The prime example the CEO mentioned is coding assistants. Things like Claude Code or OpenAI Codex. You don't just ask an agentic AI for a single line of Python code anymore. You tell it to build a new feature for your app.
And then it just goes off and does it.
It acts as an engineering partner. It writes the code, it runs tests, it identifies bugs, and it rewrites its own work until a feature functions. To facilitate that kind of continuous, iterative loop requires exponentially more compute power than a simple text prompt. It's software-eating software.
That is fascinating. So that covers the digital side, the agentic AI. But the other phrase used heavily in the call was physical AI, which frankly sounds like the premise of a dystopian sci-fi film to me.
I know, it does have a bit of a Terminator ring to it.
What does physical AI actually look like in the real world?
It is the next major frontier, and it is moving out of the lab and into reality much faster than people realize. Physical AI is artificial intelligence embedded in the physical world.
So we're talking about advanced robotics.
Robotics. Autonomous self-driving vehicles, complex industrial automation. For an AI to operate a robotic arm in a chaotic warehouse, it has to understand physics, it has to have spatial reasoning, and it has to process real-time movement.
And this isn't just some conceptual whiteboard idea for the year 2030, is it?
Not at all. The sources indicate that physical AI is already a $6 billion revenue run rate business for Nvidia today.
6 billion, wow.
Yes. They are deeply partnered with companies like Boston Dynamics to power next-generation robotics. And traditional automakers, like Mercedes-Benz, for example, are utilizing this compute to put autonomous driving tech into passenger cars hitting the road imminently.
With technology evolving from simple text to autonomous digital agents and real-world robotics, the hardware running it must age incredibly fast. I mean, if a cloud provider spent billions on chips last year, aren't those chips basically obsolete today?
That's the challenge.
How is Nvidia managing to keep customers constantly upgrading?
They are executing on a grueling, almost unprecedented hardware roadmap. The pace of innovation is staggering. They are currently successfully ramping up the Blackwell and Blackwell Ultra chips.
And demand is still high for the old stuff, too.
No, absolutely. Demand is so intense that even the older generation Hopper chips are still completely sold out in the cloud. But they aren't resting on Blackwell. They are already shipping samples of their next platform called Vera Rubin.
And Rubin is the architecture that the sources say promises up to a 10x reduction in inference costs. Correct.
Exactly right.
Meaning the actual day-to-day cost of running the AI model once it's trained will drop to 1/10 of what it is on current systems.
That is the metric that matters most to the buyers. Nvidia is now operating on a yearly rhythm, delivering entirely new AI infrastructure every single year. They have to keep driving down the cost of compute, or the hyperscalers won't be able to afford to run these massive agentic and physical AI models.
Okay, let's take a breath and look at the scoreboard so far. They have record-breaking revenue. They're maintaining unprecedented gross margins. They have a visionary roadmap that is expanding into robotics and autonomous software. And they have customer demand that literally outstrips their ability to supply.
It sounds like a flawless victory.
Right. So if everything is executing this flawlessly, why did Wall Street react with a collective sigh, sending the stock down 5% the day after this report?
This is where we run into the psychology of the market and the brutal reality of the law of large numbers. The short answer is the anxiety of sustainability.
The market is looking at that $700 billion CapEx spending figure by the hyperscalers and panicking.
Precisely. Investors are asking, is this sustainable? Will these tech giants eventually build enough data centers, hit a ceiling on consumer AI demand, and simply stop buying?
It's like a pole vaulter who just set a new world record, and the crowd is immediately disappointed they didn't jump 10 feet higher on the next attempt.
That's a great analogy.
Because NVIDIA's valuation is built on the assumption of continuous, flawless, exponential growth, it is becoming astronomically hard to impress the street. An earnings beat isn't enough anymore. It has to be a reality-altering beat.
That is the burden of being the most valuable company in the world. And when you dig deeper into the media analysis and the regulatory filings, you see that analysts are hyper-focusing on some very specific headwinds and roadblocks.
I was looking through the notes, and there was a lot of reaction to something buried deep in a 10K regulatory filing regarding OpenAI. What is the story there, and why did it spook investors so much?
It is a perfect example of market jitters. In NVIDIA's 10K filing, there was a disclosure regarding a highly anticipated $100 billion partnership and investment deal with OpenAI.
$100 billion.
Huge deal. But the note basically stated that they are still finalizing the agreement and there is no assurance the transaction will actually be completed.
So the deal is stalling.
It is stalling. And because OpenAI is viewed as the absolute bellwether for the entire AI industry, they're the makers of ChatGPT, any hesitation or uncertainty involving them causes immediate panic.
The market assumes that if OpenAI is delaying a massive infrastructure purchase, maybe the whole AI boom is cooling off.
Exactly. It's a sentiment issue.
Then there's the issue of supply chain bottlenecks.
Yeah.
I assume that if there was a backlog, it was simply because NVIDIA couldn't print the silicon fast enough. But the sources suggest the bottleneck isn't the GPU itself anymore. The constraints are entirely physical, real-world infrastructure problems.
The silicon is only one piece of the puzzle now. If a hyperscaler wants to build an AI factory today, they have to navigate a maze of constraints. First, there is advanced packaging.
Packaging the chips together.
Right. It isn't just about making the chip, it is the incredibly intricate process of stacking and connecting multiple chiplets together without them overheating or failing. Then you have soaring costs and shortages for high bandwidth memory.
Which is crucial for AI.
Crucial. Plus, you need highly specialized optical components just to connect the thousands of servers together.
And it goes beyond just the computer parts, doesn't it? It's bleeding into civic infrastructure.
Absolutely. The biggest bottlenecks are becoming land and electricity. To build one of these next-generation AI data centers, you need immense plots of land. And you need permission to hook up to a power grid that can supply hundreds of megawatts or even gigawatts of electricity.
They're competing with entire cities for power.
Yes, the physical infrastructure of the planet is struggling to keep up with the digital ambition.
Speaking of those specific component shortages, that leads us to another dip in the report, the gaming segment. Gaming revenue actually dropped 13% sequentially from the previous quarter, and the CFO explicitly pointed to those memory supply constraints as the culprit.
It provides important context for how the company is managing its resources. We have to remember that while gaming graphics cards are where Nvidia originally made its name, that segment now only makes up about 7% of their total revenue.
Right. It's a tiny slice of the pie now.
So when vital components like high-bandwidth memory get expensive and scarce, Nvidia has to prioritize. They are naturally going to allocate those scarce components to the massively profitable data center segment, leaving the gaming chips to take the hit.
We also need to address the geopolitical reality mentioned in the earnings call. The sources neutrally report a very stark statistic here. Nvidia recognized zero data center compute revenue from China this quarter.
That is a significant dynamic shifting the global market structure right now.
It's all because of export controls, right?
Yes, due to stringent U.S. government export controls, Nvidia is heavily restricted in the types of advanced compute chips they can sell to Chinese customers. While they have designed specific compliant chips like the H200 for that market, they haven't recognized revenue from them yet in this reporting period.
And the CEO acknowledged that this creates an opening for local competition.
Yes, the earnings call acknowledged that domestic competitors within China are making rapid progress in developing their own silicon. Over the long term, losing access to one of the largest technology markets in the world while simultaneously fostering aggressive local competition, that is a structural headwind they have to navigate very carefully.
So you have hyperscalers who might eventually tap the brakes, physical power grid bottlenecks, and strict export controls limiting a massive global market. How does a company safeguard its $78 billion guidance against all those vulnerabilities? If a major cloud provider delays an order, who steps in to buy the chips?
They are actively diversifying their customer base away from just a handful of American tech giants. We're seeing the rapid emergence of a phenomenon called sovereign AI.
Sovereign AI, meaning individual governments are getting into the data center game.
Precisely. Countries like Japan, France, Canada, and Singapore are investing billions to build their own domestic AI infrastructure.
Why are they doing that?
They have realized that relying entirely on foreign corporations for artificial intelligence capabilities is a profound national security and economic vulnerability. It is comparable to a country building a strategic oil reserve or investing in a national defense system. They want sovereign control over their own data and their own AI models.
That is a fascinating shift in how compute is viewed globally. How big of a financial buffer does that actually provide for Nvidia?
It is substantial. In this fiscal year alone, Nvidia's sovereign AI business tripled to over $30 billion.
$30 billion. So if a tech company decides to slow down their capital expenditures for a quarter to digest what they've already bought, you have entire nations stepping up to the cash register to fill that gap.
Exactly. It broadens their base significantly. It proves that the demand for compute is expanding well beyond the traditional cloud providers and is becoming foundational societal infrastructure, much like a nation's electrical grid, its highway system, or telecommunications network.
This has been a massive amount of information to synthesize today. Let's summarize the core takeaways from this stack of sources to bring it all home for you listening.
The overarching narrative is really a tale of two realities. Operationally, Nvidia is fundamentally executing at an unprecedented level. They are successfully navigating the highly complex transition from their Hopper architecture to Blackwell.
And they are keeping their foot on the gas with the upcoming Vera Rubin platform, too.
Right. They're pushing the boundaries of what is possible, expanding from digital agentic AI to real-world physical AI, all while maintaining historic profit margins.
But the second reality is the market environment they're actually operating in.
Correct. They are now fighting the law of large numbers. They are navigating a hyper-anxious market that is deeply worried about the long-term economic payoff of these $700 billion global AI investments. The core technology is advancing flawlessly, but the physical and economic realities of scaling that technology, power grids, memory costs, and geopolitical export controls are creating immense, unavoidable friction.
Which leaves us with a final, lingering thought to ponder as we wrap up this deep dive. We've talked extensively today about the physical limits of building these AI factories. The land, the specialized chips, the massive electricity demands.
The constraints of the physical world.
Exactly. But let's look at the other side of the equation. As we move rapidly from digital agentic AI that can autonomously write software to real-world physical AI that can drive our cars, build our goods, and manage our warehouses, how does the fundamental value of human labor change?
It's a huge question.
If the AI factories are doing the producing, does the role of the human worker shift entirely from output and creation to mere oversight and maintenance? And what does an economy based on oversight rather than production actually look like? Will the ultimate bottleneck for the AI revolution be the physical limits of our planet's infrastructure? Or will it be our own societal adaptation?
That is perhaps the most profound societal question generated by all of this financial data. It is a paradigm shift we are all going to have to navigate.
Something to definitely think about as you watch this space evolve over the coming months. Thank you for listening. Hope you enjoyed today's content. See you in the next episode.